Hello everyone and welcome back to yet another video from my channel, Interactive Education, for the best education possible from the student to the student for a better experience. And today we will be continuing the portion on physics, that is light, and we'll be taking up the first portion of the chapter, reflection of light. So basically we've looked at light as a concept in the last video and we've looked at what light is. If you have not done so, please look into the description below and find the link for that. And now we will be discussing reflection of light. Now, light travels in directions, right? And if we take a particular case, for example, let us take a mirror. And before we look into a mirror, first let us define a mirror, right? What is a mirror? A mirror is basically a smooth, polished surface. Okay? It is basically a smooth, polished surface with some degree of irregularities or very less irregularities, that depends. But it is a smooth, polished surface. We will complete this definition in a bit, but it is not complete yet. Just remember that. We'll come back to it. So let's take a general mirror. All right, let's take a mirror on which we see ourselves, right? Our plane mirror. Now, suppose this is a mirror. And on this, I have a light ray coming from this point A. So from point A, there is a light ray which is coming to this mirror. Right? It strikes the mirror. Now it's hitting the mirror, and we know that the mirror is a smooth, polished surface. So what the light ray does is that it strikes the mirror at a point, suppose B, and it jumps off from this point into some other direction. So suppose some other straight direction. So the light ray strikes the mirror, then it bounces off into another direction. Keep in mind that the light came from a medium 1. So this was the first medium. This is suppose a medium, right? Through which light is traveling. Now it came from that A point which is in medium 1, and that light ray came and struck the mirror at B. So suppose this is the mirror. It struck the mirror at B, and then it jumped back into the same medium 1, right? This bouncing off of light, this bouncing away of light on striking a smooth, polished surface is known as reflection of light. All right? So that is what we call reflection of light. The bouncing away of a light ray on striking a smooth, polished surface back into the same medium from which it came from is known as reflection of light. Right? So, can we now complete that definition of a mirror? Yes, we can. We saw that a smooth, polished surface is what we call a mirror, and that light ray strikes a smooth, polished surface and jumps back into the same medium on striking that surface, which we call reflection. So, mirror can be defined as a smooth, polished surface through which or by which reflection of light takes place. Through which or by which reflection of light takes place. Because it is striking that particular surface, then it is bouncing away. So because of that bouncing away, it is hitting a smooth polished surface, reflecting back into the medium, so that mirror is facilitating reflection. And hence, a mirror can be defined as a smooth, polished surface by which reflection of light takes place. Right? So this is what we call reflection of light. Right? Now there are some laws of reflection of light. Now laws. And this also, we have done this in our lower classes, but we have to continue this anyway. So laws of reflection of light. Right? Now, if there is a surface, suppose this is a mirror, Okay, suppose this is a small plane mirror. And on this mirror strikes a ray of light. And obviously it will reflect back, right? Now this ray which is striking the mirror, okay, this ray which is striking the mirror from point A, suppose, and striking the mirror at suppose point B, this ray is called the incident ray. This ray is called the incident ray. This ray which is hitting the mirror, right? That is called the incident ray. Now suppose it is reflecting back to a point C. So the ray which is striking the mirror is the incident ray, and the ray which is reflecting from the mirror from point B, this BC ray is called the reflected ray, right? Reflected ray. Now, between the incident ray and reflected ray, the point of reflection, right, this B point, which is the point of reflection, through this, we assume a perpendicular imaginary line, right? We assume a perpendicular imaginary line, and this perpendicular imaginary line, which is perpendicular to the surface of the mirror, and it is an imaginary line, we call this the normal, right? We call this the normal. So it is an imaginary line which is perpendicular to the mirror, and also it is passing through that point of reflection, right? And it is perpendicular to the surface of the mirror. This imaginary line is called the normal. Now, this is a basic structure and basic arrangement of the different rays and different things present in a reflecting case, right? Case of reflection. So once you've understood this setup, we can now easily understand the laws of reflection of light. Now, there are two main laws of reflection of light. The first law is that the angle of incidence is always equal to the angle of reflection. This is the first law, okay? So basically here you understand angle of incidence is equal to the angle of reflection. So this is equal. So what is angle of incidence and what is angle of reflection? Well, let's have a look. This angle between the incident ray and the normal, not the incident ray and the mirror. That is a misconception. It is, and people they take up this concept and they do mistakes in it. It is not correct. It is the angle between the incident ray and the normal. This angle. This angle is called the angle of incidence. Okay, denoted by I. Then the angle of reflection. I think you can guess this. This is the angle between reflected ray and the normal. This angle here. Right? This angle is the angle of reflection. Now, it has been seen that the angle of incidence is always equal to the angle of reflection. Right? That's the first law of reflection. Right? That's it for the first law of reflection. Now we come to the second law of reflection. Second law of reflection states that the incident ray, the reflected ray, the incident ray, the reflected ray, and the normal lie on the same plane. So what does this mean? So the incident ray, the reflected ray, and the normal lie on the same plane. Here you can see that this is a plane surface, right? If you can just take this case here, this is a plane surface. Okay. Okay, this is my plane surface. Now on this plane surface, you can see that this is the mirror, this is the normal, this is the incident ray, this is the reflected ray. So you can see that this is whole one plane area, one plane surface, right? This whole area is one plane surface. So all three rays and all three lines lie on the same plane. The incident ray lies on the same plane, reflected ray and the normal, they lie all on the same plane of the mirror, right? So that is the second law of reflection, right? I hope that's clear to each and every one of you. So these are the two laws of reflection of light. Angle of incidence always equal to the angle of reflection, and that the incident ray, the reflected ray, and the normal lie on the same plane. Right? I hope that's absolutely clear to all of you. Right? So these are the two laws of reflection of light. So once we've understood the concept of reflection, now that we are done with understanding what reflection is, we can now move into mirrors in a more detailed manner, right? Mirrors. Right? Now, mirrors are of two types. We have basically classified two kinds of mirrors. We've seen two kinds of mirrors, and we've classified mirrors on that basis. So, mirrors have been seen to be of two kinds. There are plane mirrors, and there are spherical mirrors. Okay, there are plane mirrors and there are spherical mirrors. Plane mirrors are those just plain old mirrors, right? They are just plain old surfaces which are smooth reflecting surfaces. For example, this one. You can see that this is a plain reflecting surface, right? No kind of change in the structure or in the shape of the mirror. It's just a simple plain old mirror, okay, which we use in our daily lives. Okay, that mirror. Spherical mirrors are then again of two kinds, right? Spherical mirrors are basically spherical shaped. Spherical shaped or spherical shaped. Or they have been derived from a sphere. They have been taken out from a sphere, right? You can even say that. Or taken from a sphere. Let's see how that happens. We'll see how that happens. So they are taken from a sphere, or they are spherical shaped. A better term would be that they're taken from a sphere. Let's see how. So there are two kinds of spherical mirrors. There are concave mirrors and there are convex mirrors. Okay, concave mirrors and convex mirrors. Now, concave mirror looks something like this, right? So suppose this is the sphere from which I'm taking the mirror, right? Suppose this is the sphere from where I am taking the mirror, right? Now, if the sphere has an outer reflecting surface, which is not reflecting. Suppose this is the part of the mirror. This is the sphere from which the mirror is being cut, and the outer part of the mirror does not reflect, right? Then, if I cut out a piece from the sphere, suppose this is my piece which I'm cutting out from the sphere, and then this is the area I'm cutting out. Then you can see that this part is which is going to reflect. Right? Can you see that? So this portion is going to reflect. This portion is not going to reflect. So the mirror which has an, which is obtained from a sphere, which does not have an outer reflecting surface. You can see that this surface is not reflecting. So you can see it is a non-reflecting surface. Non-reflecting surface. Whereas if you look at the inner part of the sphere, you will see that this part is the reflecting surface. So when I take out such a mirror from the sphere, it will look something like this. Okay, I'm just using the same color. So if I take the mirror like this, okay, so this is going to be the mirror I'm going to get. If I'm just going to remove this part, this is going to be my reflecting surface, and this part is going to be my non-reflecting surface. Right? You can remember it like this. If there is a cave-shaped mirror, you can see that this is a cave. Okay, you can assume it to be a cave. See? Cave. This cave-shaped mirror is going to be my concave mirror. right? Cave shaped. Can you imagine that? This is a cave and I'm entering this cave, right? So this kind of a mirror which is open outward and its inner surface is the reflecting surface. This is the concave mirror. Then we go on to the next kind of mirror, which is the convex mirror. Now, if we look at the sphere of the convex mirror, of the sphere or the sphere from which the convex mirror is obtained, here the inner surface is the non-reflecting surface. So you can see that this surface right here, which is inside, this is the surface which does not reflect. Right, this is the non-reflecting surface, this surface which has been coated with a silver lining or something and it does not reflect. Right? Now, if I cut out a part, okay, if I take out a part, you will see that this outer surface is the reflecting surface. Okay, outer surface is the reflecting surface, and this inner surface is the non-reflecting surface. It does not reflect light, but this outer surface does. So if I take out this part of the mirror, which is going to, if I take out the mirror from the sphere, you will see that I'm going to get a mirror like this. Right? This is the mirror I'm going to get. So this is my convex mirror, right? It is half an X. Can you see that? We write an X like this, right? So you can just put this, and this is going to be my convex. Half an X. Right? I hope that's absolutely clear to each and every one of you. What is a convex mirror and what is a concave mirror? Concave mirror has an inner reflecting surface and outer non-reflecting surface. And this convex mirror has an outer reflecting surface and inner non-reflecting surface. Right? That's absolutely clear, I hope. The types of mirrors. Plane mirror and the spherical mirrors. So this was it with this video. This video discussed the laws of reflection of light, the concept of reflection of light, and the type of mirrors. Thank you very much for joining me today. In the next video, we will be discussing a lot of detail about the type of images formed by the mirror, how images are formed by the mirror, and what kind of images are formed by the different kind of mirrors and their properties. Thank you very much for joining me. Goodbye, stay healthy, stay smart, and do keep studying. Bye-bye.